Hello everyone. Today we're going to see how to sketch functions using derivatives. So let's start off with things. First of all, we'll consider a simple example: x square minus 4x plus 5. And this is the function we're going to draw. So we're going to use derivatives. So we will find the first derivative of this function, that is f dash x. So the first derivative of this function is going to be 2x. The differentiation of x squared with respect to x, that's going to be equal to 2x, and differentiation of this term 4x with respect to x is going to be 1. So it's going to be 2x minus 4. So whenever you are sketching a graph, you have to consider, the first thing you have to consider is you have to find the turning point or turning points. So in order to find the turning point, you have to equate the first derivative that you obtained to 0. So if dash, when f dash is equal to 0, you have to find the x value which satisfies this equation. So when f dash x is equal to 0, 2x minus 4 has to be equal to 0. So what is the solution here? So x is equal to 4 by 2. So x is going to be equal to x is going to be equal to 2. Right? So which means x is equal to, when x is equal to, f dash is equal to 0, which means there's going to be a turning point when x is equal to 2. When x is equal to 2, so you have to find the corresponding y value, that will be equal to f2. So what f2? Substitute 2 here. 2 square minus 4 into 2 plus 5. So y is going to be equal to 4 minus 8 plus 5. 4 plus 5, that's going to be 9. So y is going to be equal to 1. So the coordinate of the turning point, is 2, 1. Right? It's a turning point. So I recommend you to pause the video and try to redo it by yourself. And after doing it for yourself, so next we will move on how to we'll go to the next step of how to sketch this function. All right. So far, we have found the first derivative of the particular function that we are drawing, if dash x is equal to x minus 4. And in addition to that, we actually equated the first derivative to 0, and we found the solution, the corresponding solution of that one, and we found the turning point. So in this section, what we're going to do here is we have to find whether this particular point is a maximum point or a minimum point, which means which type of turning point is this. It can be, because functions mainly have two types of turning points. One is maximum point, one is minimum point. So we have to see whether this particular point is a maximum point or a minimum point. If you have a basic algebraic knowledge, you can say that this is a quadratic effect. If x is a quadratic function, so a quadratic function, and the coefficient of x squared is a positive number, so this function has to have a minimum point. We can say that using algebraic knowledge. But here we are using calculus. So how can you find what type of turning point is this? So draw a number line. Draw a number line for x, right? We know the value which makes the value of x, which makes this first derivative 0, is 2. So we have to consider the values which are smaller than 2 and which are greater than 2 in order to find the turning point. So definitely there's going to be a turning point when x is equal to 2. We know that because 2, 1 is the turning point. So in order to find the turning point, you have to draw a table. So we have to check the values which are smaller than 2. This region is x is smaller than 2, and this region is x is greater than 2. So here we have to check the first derivative, the sign of the first derivative of fx, whether f dash x is positive or negative. You have to find that. You know the expression for f dash x. So what you have to do here is you have to take a number which is smaller than 2 and you have to substitute it here. Right? Consider a number which is smaller than 2. Let's say 1, substitute it here. So f dash 1 is equal to, you have to substitute 1 where you find x. So 2 times 1 is 1, right? This is 1. Right? Minus 4. Right? You don't have to find the value actually. You have to check the sign. 2 minus 4, that is negative. So when x is smaller than 2, f dash x, the first derivative is negative. Alright. So what happens when x is greater than 2? When x is greater than 2, you have to check f dash 2. Which means in f dash x you have to, not 2, okay. A number greater than 2. Right? Take whatever value you want. You can take 3, 4, 5, 6, 7, 8, whatever, right? Okay, 10. That's up to you. So I'm taking value greater than 2. So I'm taking, let's say 4. So I'm going to see what's going to happen when I substitute 4 instead of x here. Right? 2 times 4. Minus 4. Right? 8 minus 4. Yes. That's 4. That's greater than 0. This is more than 0. When I substitute a number which is greater than 2, f dash x is going to be a positive number. So when x is greater than 2, it's going to be positive. Yes. So the meaning is, right, when x is more than 2, the first derivative of fx is negative, which means, right, when x is smaller than 2, fx, right, this is f dash x, and the third row you have to add is fx. Fx will decrease with x. That's the meaning. When f dash x is negative means that particular range fx or y value y actually decreases with x. Here x is greater, when x is greater than 2, if the sign of f dash x is positive, which means when x is greater than 2, fx actually increases with x. Right? Try to understand this one. When x is smaller than 2, f dash x is negative, which means fx actually decreases with x. When x is greater than 2, fx actually increases with x. So this actually gives you the basic shape of the graph. So you can see it here, right? It's decreasing and here it's increasing, which means there's going to be a turning point here. There's going to be a minimum point here, a minimum turning point. So we can say hence 2, 1 is what? It's the minimum point. It's a minimum point. Hope you understood it. So I recommend you to pause the video and just go through the things that I went through and try to figure this out. So after doing this, we can move on to the next section. Alright. So before moving on to the sketching part of the graph, there's one more thing we have to do. What is that? So we have to see, right, when x tends to plus or minus infinity, when x goes to infinity, to a bigger value, it can be positive infinity or negative infinity. So when x tends to plus or minus infinity, what happens to fx or what happens to y? So we have to find the y value when x goes to infinity. We have to consider them separately. X square minus 4x plus 5. What happens when x goes to infinity? Will this function have a finite number or an infinite number? We're going to check that one. I hope you have a basic knowledge in limits. If you don't have a basic knowledge in limits, I bet it's better to try to study some limits and come back to this one. So when x tends to infinity, plus positive infinity, what's going to happen to y? Y means fx, right? You can consider fx is what? No problem. So y is equal to, when x tends to positive infinity, you cannot substitute this one. Okay. So what you have to do? So what can we do when you are applying limit and when you're substituting an infinite value for a polynomial like this? How to handle this one? Always remember, if you encounter a situation like this, you have to take the term with the maximum power as the common factor. Right? I'm taking x square as a common factor, so it's going to be 1 minus 4 over x plus 5 over x square. If you take x square as a common factor, it's going to be 1 minus 4 over x plus 5 over x square. Right? Y is equal to limit. Yeah, limit. When x tends to positive infinity. Now you can substitute. Right? If you substitute infinity here, positive infinity here, this will become 0. And this will also become 0. So y is equal to limit. So when you substitute positive infinity here, this will become 0, this will become 0. So 1 minus 0 plus 0, it's going to be 1. Right? That's number 1. Here you have x squared. If you substitute positive infinity here, infinity into the answer that you are going to get here. So if you substitute positive infinity here, you will be getting positive infinity into, if you substitute that infinity part here, this will become 0 as well as this one. Both of them will become 0. So into 1. So positive infinity into 1, you can say y tends to positive infinity. When x is positive infinity, when x tends to positive infinity, okay, just take it separately. Yeah? First of all, I'm taking that x goes when x tends to positive infinity, what will happen to y? Y will be positive infinity. I hope you can understand this one. Right? Okay. Similarly, you have to see what happens when x tends to minus infinity. You have to do the same part here. Y is equal to limit when x tends to negative infinity. You have to see what's going to happen to x square minus 4x plus 5. So y is equal to, you have to do the same thing. You have to take x square as a common factor. So limit x tends to minus infinity. I am taking x square as a common factor. It's going to be 1 minus 4 over x plus 5 over x square. So y is equal to, you don't have to repeat limit here. So just substitute. So if you substitute minus infinity here, whether if you substitute plus infinity or minus infinity, if you substitute a value here, always remember a constant over infinity will always give you 0. Constant minus what's a constant over infinity. Substitute infinity here, it's going to be 0. This one is also going to be 0. So the remaining one, the remaining value you're going to get is equal to 1. So 1 into, if you substitute minus here, minus infinity square, that's going to give you positive square. Because square of a negative number is going to be a positive number. Similarly, square of minus infinity, that's going to give you positive infinity into 1. So y tends to plus infinity. Right? Even when x tends to minus infinity, y goes to positive infinity. Okay? Alright? So I hope you understand this one. Please pause the video and try to completely understand and try to do it by yourself, and we'll move on to the next section. Alright students, so far we have obtained these three information. First thing, we found that 2, 1 is a turning point, and it has at that particular point that is a minimum point. Right? And second and third things are, when x tends to positive infinity, y goes to positive infinity. When x goes to minus infinity, negative infinity, right, y goes to positive infinity. So now you have to compile all this information and you have to draw the graph. Right. So we're going to draw the graph now. This is the x-axis and this is the y-axis. This is the origin, 0, 0. Yes. So we found that 2, 1 is a turning point and it's a minimum point. Yes. So let this point be 2, 1. This is 2 and this is 1. Yes. This is the minimum point. The second thing you have to consider, when x goes to positive infinity, it means when x goes, when x increases, right, in the positive side. Right? As x goes towards the positive infinity, y also goes towards positive infinity. So the graph will go like this. right? When x goes to negative infinity, when x actually increases in the opposite direction, right? Okay, what happens to y? Values of y will go to positive infinity, right? As the x value actually decrease, right? Decrease in this way, y is going towards positive infinity. It's going to increase towards the positive side of y, right? So here's the turning point here, right? Y will go towards positive infinity, and here also it goes to positive infinity. So the graph will be like this. Right? It's a turning point. Graph will go like this. When x increases, it will go towards infinity. Without any, it will go this way. Right? When x decreases here, right, little by little will go to positive infinity. Right? I hope you understood this one. Okay? So this is the graph of y is equal to x square minus 4x plus 5. Right? And you can see here this graph is actually intersecting this y-axis. Right? It's better if you can find the points. It's better if you denote the points where the graph actually intersects the axes, right? It can be x-axis or y-axis. This graph is obviously it's not intersecting the x-axis, right? It is intersecting the y-axis. So you have to find this coordinate as well. So how can you find this one? So you have to find the point where the graph actually intersects the y-axis. So in order to find that point, you have to make x 0. You have to find the value of y when x is equal to 0. Just substitute it. So we know that, yeah, the function is what? Yeah, this is a function. So instead of x, substitute 0. That's very simple, right? 0 squared 0. 0, these two will disappear. So y is going to be 5. So 0, 5 is the point. This is the point. 0, 5. The coordinate of this point is going to be 2, 1. So this is the graph. So you have to compile all the information that we received. So some might be wondering, right? Should we use this method to draw this quadratic function? Because there are easier ways to sketch quadratic functions, right? The reason I chose this function is just for understanding purpose, right? So you can understand this one easily, right? Because you have to use all these methods that we used for other functions, other hard functions. Let's say, just imagine it's a higher order function, right? Like x to the power 4, like that, right? Or it can be a rational function, right? So you have to use it in order to sketch those graphs. So in order to make you understand the process, right, I chose this simple function. So in the coming videos, we can discuss about different types of functions. For example, rational functions and things like that. Right? Okay. So try to understand this process and try to repeat these things. Whatever I have taught you, and try to understand this section. So thank you very much for watching my video.